Hello, this is Buru reporting for First Updates Now. Today I'm joined by TehnoZ from Romania. They are currently holding the Romanian record at 372 points and are the winning alliance captain of the Bucharest League Tournament.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
Okay guys, let's start with your intake. How did you arrive this intake? It seems to be working really well with the stack, and I want you to take me to how it works and what iterations you took to get here.
For the intake from the first hour of the season, we decided that we need an active intake because you don't really have precision to see on the other side of the field what you are collecting. So you need something that would just go in and get out with the pixels. Okay. So this is our sixth variant of the intake. We've come across from an intake that without a button roller. These two components, these two have been in different positions. The mobile one was here on some variant, but generally we had problems from taking from the stack in the autonomous period. Now we've come across to a variant that intakes it quite instantly on every single pixel individually from the stack. So we are pretty satisfied with this. Also, when the pixel is on the ground, we can collect it very fast. If they are placed one by one or one on top of each other, there is no issue. And yeah, we are very proud with this intake as we've worked a lot for it, and it works really good at the moment.
I honestly am very impressed by your guys' autonomous. Can you take me through what makes it work so well?
Okay, sure. So for localizing, we are using we tried to use three odometry wheels. We are using opti-odometry. Can you flip the robot, please? Yeah, so you can see them here. We have them placed in the front of our robot. But while tuning Roadrunner V1, we found out that the IMU is more accurate than the three-wheel setup. So right now we are using only two wheels with the IMU from the expansion hub. Because we encountered some ESD issues while using the control hub one. And we experimented with distance sensors from intaking during the auto period, but we found out that it's much better to only use the localization. Also, we have pretty smart detection. So when we're doing the far side auto, using the camera at the front of the robot, we are looking for the pixel that was placed before on the backboard, the yellow one, and we will place ours next to it, so we get all the points for the for placing the yellow pixels on the backboard. Also, in Teleop, we are using a lot of automatizations. We also have in the outtake box two color sensors to detect when we intake two pixels, and after the robot sees that it has two pixels in it, it reverses automatically and stops the intake without the need to press a button to stop it. We use this in auto as well to detect at the stack if we have pixels or not. And I think that's pretty much it about our auto.
That's great. Okay, please talk to me a little about your outtake. I love how precisely you can place mosaics, scoring a 3 in almost every match you played.
Regarding the outtake, this is the second variant. In the first variant, we used this type of claw that would go inside the pixels, and it uses like the car engine, a camshaft that pushes these rods depending on how much you rotate the servo. If you rotate it 45 degrees, the first round of camshafts extend and block the pixel, and rotate it 90 degrees. Both of them extend and block the pixel. This variant was very hard to build because it requires very small things, very small pieces in the interior of the claw, and they were really hard to print and assemble. And one of the biggest issues with this system was placing on the board, as the first pixel would come off right away, but the second one needed to be wiggled, and we lost a lot of time on the outtake, so we decided to switch to this box. It is very simple. The intake pushes the pixels one by one into the box. This clap blocks the pixels and can release them one by one or two at the same time. To score mosaics, we use a very interesting position. Normally, we place the box at this angle perfectly with the backboard. But when you want to score very precisely, we turn it like this, and the pixel comes off at the exact point, at the exact spot, which gives us really nice precision. That was really helpful, especially in this competition today.
We only use this position when we want to make mosaics really high, because at the start of the season we went with only three with three slides, because we had a different outtake. So after we switched to this box, we couldn't reach the highest part of the field. So then we had to use our arm to raise it a little bit higher, and this was the only way to do it. To score pixels in precise with a high precision, we are dropping our box right where the pixel needs to be, and then we will lift it to make sure the pixel won't bounce to another position.
Okay, yeah, that's amazing. Okay, guys, so you continue to impress me with your consistency. You guys really know how to win competitions. Being the winning alliance captain at the Romanian Nationals last year, and then doing it again at the Bucharest League Tournament, which is arguably, I think, the most challenging region in Romania. Yeah, you guys are amazing. So let's end off with your endgame scoring mechanisms. So I saw that your drone is incredibly consistent. Can you take me through that?
For the end game, we've noticed that at our practice level at the moment, we can go release the airplane that really hits the first or second zone, which is very nice because it really helped us in the matches and in the end game points. For the hanging, we use these steel plates, and the same. What?
Aluminum plates.
Yes, aluminum plates. Sorry. For the motors, we use two. You can't really see them because they're hidden here. We use two 13.7 to 1 ratio motors with 5 centimeter spools. This way, we've maximized the lift speed, but at the same time, used it to hang in the endgame period. Generally, we can hang, get one cycle on the backboard, and deliver the airplane in the endgame period. In some cases, we can go for 2 cycles, but today mostly 1 cycle.
Great. Guys, this has been amazing. This is an overall amazing robot, and I love to see it working in competitions. Yeah, you guys are great, and this has been Buru reporting for First Updates Now.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Most live shows can be found on the First Updates Now YouTube channel, live competitions at twitch.tv/firstupdatesnow, and join our Discord at discord.gg/firstupdatesnow. Check our other social offerings on TikTok, Instagram, Facebook, and Twitter.